All right, here we go. Week 2, day 2. We are graphing radicals still. I want you to start today with a little bit of an exploration. So what I'm going to have you do here, I'm going to put up 4 functions, and I want you to try to match the function with the graph and then try to identify the domain and range if you can. So I'm going to pause here and let you do that. Alright, so as you can see, these were radicals that were square roots this time and not cube roots. So not the same as what we had done the other day, but still you can use the same concepts. So for example, this one right here, g of x is the square root of x plus 2. That plus 2 is on the inside, which is going to move it left. And the only graph that moves to the left is graph A. B says square root of x minus 2. Okay, that minus 2 in here would mean that, hey, it's going to move to the right, and the only graph that moves just to the right is D. C is square root of x plus 2, and then a minus 2 on the outside, so that means it's going to move to the left and down. Okay, so the only graph that moves to the left and down is B. And that leaves process of elimination, but it also is the only one that's reflected, and that is graph C. Now, domain and ranges, if you gave them a try, they're a little bit different. Okay, these domains do not go from negative infinity to infinity. Okay, the domain on graph A starts at negative 2 and goes to infinity. The domain for graph B also starts at negative 2 right here and goes to infinity. The domain for graph C again also starts at negative 2 and heads to infinity. And then the domain for graph C, or D I mean, right here is the only one that starts at positive 2 and heads to infinity. Okay, now the range, similar concept here. A, the range right here at this point is at 0 and it's going upwards, so it's heading to infinity. The range here on B, it's starting right here at this point, which is at negative 2, and again it's heading upwards, so to infinity. And the range here on C, this one's a little bit different. It starts here at 0, but this time it's going downwards. So that's why we're going to say negative infinity to 0. That negative infinity must come first. Okay, some of us missed that. Sorry guys, I didn't realize you could not see that on the bottom of that page there. There we go. Some of us did not do it that way on our quiz, so make sure you're conscious that the negative infinity has to come first. Alright, and then finally, this one right here, it again starts at 0 for the range, and it heads to infinity. Okay? Now, we today are graphing again radicals, but this time it's square root. Okay? So again, that's our parent function. So this one right here is our parent function. Okay? When we graph, remember we'd like to make this table. Now, again, I can try to use that negative 2 like I tried to last time, but y equals the square root of negative 2. We know that we can't square root negatives, and that means it's going to be imaginary. Okay, so negatives might not be the right thing to start with in our table here. So, when we start here, if I can't do negative 2, well, that means I also can't do negative 1. So what if I start with, alright, 0. Can I square root 0? Sure can. It's 0. What would be another good number to square root? Some of you right now are probably thinking 4. Yeah, 4 is a great number to square root. Well, the square root of 4 is 2. Another good number to square root if I keep going, 9. 9 is a good number to square root because the square root of 9 is 3. I could keep going to 16, I could go to 25, but that gets a little bit big. I want something that's between that 0 and 4. Well, 1. Square root of 1 is 1. And if I graph those ordered pairs, I end up with a graph that looks just like this, that the domain and the range So the domain, this time, it can't go any further than this starting point right here, which is why I put a bracket that it's starting at 0, and as it's moving to the right, it's going to infinity. Okay, and on the range, again, I'm starting at this point, so it starts at 0, and as it's going to move right, it's going to continue to move up. Okay, so that is why we're going to say it's moving to infinity. Remember, your big ideas math is going to name these a little bit differently. Your big ideas math, this 0 to infinity for the domain is going to mean x is greater than or equal to 0. Okay, starting at 0, and it's everything greater than. Oh, my bad, wrong direction. Starting at 0, and it's everything greater than going to the right. Range is the same thing, only its y is greater than or equal to 0. So starting here at 0 and then moving in the positive direction. Now, this next page should come as no surprise here that, hey, guess what? Everything's the same. So I'm going to pause here. I'm going to write out what it is. Nothing has changed from what you already know. Alright, all of those things are exactly the same as they have been for every single function. So none of that's new. Alright, so here we go. That f of x equals square root of x minus 2 plus 4. What I want you to go ahead and do is I want you to name the transformations because you can. Now we are going to name the transformations as well as graph and name the domain and the range. So I want you to pause here and I want you to write down the transformations. Alright, hopefully you wrote down, hey, it's moving to the right 2 units and up 4 units. When we go to graph this, I'm going to use that same parent table I just created, that 0, 1, 4, and 9, because I can square root those numbers, so you get 0, 1, and 2, and 3. When I make those transformations, remember I'm moving up 4. Okay, that's a positive action, and also moving to the right 2 is a positive action. Okay, so go ahead and make those changes to your table and graph those values. I'm going to pause here and do the same thing. Alright, those are the values you should have on the table when you add 2 and add 4. That is what your graph should look like off to the side over there. Now, domain and range. Square roots have a starting and a stopping point, meaning they don't go in both directions for domain. Okay, so for the domain, it is starting right there at the value of 2. And as it's moving, it's going to keep moving right, which means that it's going to head here to positive infinity. Now, just a reminder that big ideas math, okay, that 2 to infinity means that x is greater than or equal to 2 because infinity is bigger than 2. Now, as that graph is going to continue moving to the right, I'm going to talk about range here, it's also going to continue moving upwards. Okay, which is why the range is going to start at 1, 2, 3, 4 right here. And it's going to head to infinity. Your big idea is math. Remember, that means your y values, because it's heading to infinity, it's greater than or equal to 4. Okay, so here's my next example. We're going to do those same things. We're going to name the transformations. Let me get lazy here and write T. We're going to graph using that same table. And then we are going to name domain and range. I want you to pause here, and I want you to name the transformations and make the changes to your table here for the graph, and then I will pick back up and talk about domain and range. So pause here, do all those things, do the domain and range if you're comfortable, and then check yourself with what I have as I'm talking about it. Okay, those are those transformations. Vertical stretch by 2, left 3 units, down 1 unit. I made those changes to the table there. Now remember, you must multiply by that vertical stretch before you subtract. There is my ordered pairs, and there they are on the graph right there. Something important that I forgot to mention on the last couple times I've been drawing this. This radical function does not have an arrow on that bottom half. Okay, it just starts at this point right here as a starting point. Okay, which would mean that the domain for this one, as I move here to the left, 1, 2, 3, it starts at -3 and it's heading to the right, so it's heading to infinity. The range here at this starting spot is down 1, so it's starting at -1 And remember, as this is moving to the right, it is going to continue to move upwards. So that is why that the range is going to be from -1 to infinity. One more friendly reminder that, hey, big ideas math. This is x is greater than or equal to -3. Y is greater than or equal to -1. Okay. Now, I have a third example. I'm going to go ahead and pause and have you do the entire thing, domain and range included, and then I will unpause, talk about it, and that is our last example today. Alright, there are those transformations and how those transformations affect the graph of the table. There's the graph over there to the side. You're going to notice that it's been compressed this time instead of stretched out or normal. Now, domain still moves to the left for it, starts at that point right here. The reflection means that, hey, it's going to curve downwards instead of upwards this time. The domain, though, that does not affect that this is greater than or equal to -4 for that big ideas math. Okay. Now, the range, though, as it moves to the right, it's going to continue to move downwards. I'm not sure why my writing's not coming up here. Here we go. As it moves to the right, it's going to continue moving downward, okay, which is why it's important that your range starts with that -infinity, and then it stops here at 0, not -4, because the y value is 0. So big ideas math, that would be y is less than or equal to 0. Thank you.